So on this problem, we want to solve the system of equations. Now it looks like all the other systems of equations that you've been doing using matrices in the past. So we're just going to treat it like it is until we realize that it might be a special case, which is what we're trying to cover in this lesson. So we have our augmented matrix, which in this case is going to be 2, 4, negative 6, 10, 1, negative 1, 1, and 4. 1, 2, negative 3, and 7. So my first step is to try to get a 1 in the upper left-hand corner. One easy way of doing this is to switch two rows that already has a convenient 1 where in the right position. So I am going to just take row 1 and interchange it with row 2. Now notice I could have done row 1 with row 3. Both of the other rows have a convenient 1, so I'm just going to go ahead and take the first and the second and switch them. It kind of doesn't really matter which one you do. Sometimes it comes out easier without less fractions if you do it one way versus the other. We don't really know. We're just going to have to pick one and kind of go with it. So row 3 stays the same. I'm going to switch row 2 and row 1. Okay, and now I am going to do my little progress report. Do I have a 1 where I want it? Yes. Do I have zeros below? Well, no. So that's what I really want to get. I want to get my zeros below. So in order to get zeros below, I'm going to use the rule to get a 0, which says take the opposite number. So I'm working with 2. So the opposite of 2 is negative 2. Multiply it by the row with the 1 in it. In that case, this is row 1. Add it back to the row you're manipulating. Put it back in that row. At the same time, I'd like to do make the 1 a 0. This is the only step that you can really do 2 rows at the same time. So the opposite of positive 1 is negative 1. Times it by the row with the 1 in it, which is row 1. Add it back to the row and put it back in the row. So this one, to get zeros requires just a little bit more work. So I'm going to have to do that on the side of my paper. Notice that row 1 stays the same. So I'm going to do negative 2 times row 1 plus row 2. I'll do this one horizontally and I'll do the other one vertically. You should just pick which method you like and stick to it. Okay, negative 2 times row 1. So my row 1 is 1, negative 1, 1, and 4. Add it to row 2, which is 2, 4, negative 6, and 10. Negative 2 plus 2 is 0. 2 plus 4 is 6. Negative 2 plus negative 6 is negative 8. Negative 8 plus 10 is 2. So for my second row, I should have 0. No big surprise there. That's what we were trying to have happen. 6, negative 8, and positive 2. In orange, I'll do it the other way. Negative 1 times row 1 plus row 3. I'm going to do this horizontal. Again, you pick the way you like and stick with it. So if I take the negative 1 times the entire row, that basically just changes everybody's sign. Add it to row 3. So I'll put row 3 below it. And add down, which gets me in my third row 0, 3, negative 4, and 3. Okay, so let's do a little progress report. Do I have a 1? Check. Do I have zeros below it? Check, check. The next thing I'm looking for is to get a 1 where the 6 is. So if I look back to my instructions about how to get a 1, I don't have anything convenient that I can switch. Usually that only happens on the first step. So the rule is to take the reciprocal 1/6 times the row and put it back into the row. Notice that I'm not changing row 1 or row 3. So those are going to come down. And then I'm just going to take the whole row and multiply it by a 1/6. If you prefer, you can think of it as divide by 6. 0 divided by 6 is 0. 6 divided by 6 is 1. Negative 8 divided by 6 is negative 8/6, which reduces to negative 4/3. Negative 8/6 reduces to negative 4/3. And then we have 2 divided by 6. 2 divided by 6 reduces to 1/3. Now, this has fractions, and at this point, lots of students are like, oh no, I don't want to finish this. This looks too hard. But it's not that bad. Fractions are okay. Sometimes they do pop up in your matrices, and there's nothing you can really do about it. So let's do our progress report. Do I have a 1? Yes. Do I have zeros below it? Yes, yes. Do I have a 1 in the next column? Yes. So the next thing I'm looking for is to get a 0 below. All right, if I follow my instructions about how to get a 0, and I do it in the right order, I won't mess up any of the 1s and 0s I've already had. So to get a 0 here, I'd have to take the opposite sign of positive 3, which is negative 3, times it by the row with the 1 in it. Now the row with the 1 in it, I know it looks like both of the elements above the 3 have 1s in it, but we're talking about the ones down the diagonal here. These ones, so in this case it has to be row 2. So negative 3 times row 2, which is the row with the 1 in it, add it back to the row. My first and second row are going to stay the same. And my third row requires a little bit of effort. I'll do this one vertically, so I have negative 3. I'll do this one vertically. Negative 3 times row 2 plus row 3. My row 2 is 0, 1, negative 4/3, 1/3, plus my row 3, which is 0, 3, negative 4, and 3. 0 plus 0 is 0. I didn't want to mess up my zeros anyway. Negative 3 times 1 is negative 3 plus 3 is 0. No surprise there. That's what we were hoping to have happen. Now here's where it gets a little tricky. So the 3 and the 4/3. Notice the 3 is a numerator and the other 3 from the 4/3 is a denominator. So those just divide out, and a negative times a negative is a positive 4. 4 plus a negative 4 is 0. Now I didn't mean for that to become a 0, but it just happened. On this last one, we have the 3's dividing out, which gets me negative 1 plus 3, which is 2. So my last row is 0, 0, 0, 2. So let's do our little progress report. Do I have a 1? Yes. Do I have zeros below it? Yes, yes. Do I have a 1? Yes. Do I have a 0 below it? Yes. Do I have a 1? Well, no. And there's nothing, I can't divide by 0, so there's no rule that's going to help me get that 0 to become a 1. I can't do it. So what I'm going to do is I'm going to just try to do my back substitution from here. I have x minus y plus z equals 4, y minus 4/3 z equals 1/3, and then 0 equals 2. Wait a minute, 0 never equals 2, so this is not true, which tells me this is an inconsistent system, and my solution is no solution. There isn't any number that when I plug it in for x, y, and z is going to get me an answer, because 0 never equals 2. These systems don't actually work together to create one unique solution or even an infinite amount of solutions, so therefore there is no solution for this problem.